All right, hello everyone. We will discuss the problem robot collisions, and it's the last problem of Leetcode weekly 351. So the problem statement says that you have a set of robots, and these robots are present at some positions. So uh, in the original array, the positions are not in a sorted order, but here I have written them after sorting them. Okay. Apart from that, each robot also has some health and also has some initial direction. So here the directions are L, L, L. L means it will move to the left and R means it will move to the right. And all the robots have the same velocity. Suppose there are two robots which are colliding. Maybe let's look at these two robots. Since this is moving to the right, this is moving to the left. These two robots will collide, right? So in a collision, what happens is whichever robot has the lesser health will die. So if suppose this one has a health of 6 and this one has a health of 10, then this robot will be destroyed and this element's health will be updated. And if both of the robots have equal health, then they both will be destroyed. In this case, both will be destroyed. And suppose there are three robots like this. This robot has a health 10, this robot has a health 10 as well. Then what will happen is in this configuration, these two robots, this is health 10. So initially this robot is moving to the right, this is moving to the left. So these two will collide and this one will be destroyed. This robot will not collide with this before this one does because it's at a like farther position. So first these two will collide, then this will die. This health will become 9. Then since this is dead, this robot will collide with uh, this robot, and since the health here is 9, the health here is 10. This robot will die, this robot's health will become 9. And in the end, this robot will then keep moving to the left. So the problem just asks you that at the end, which all robots will be remaining. Okay. So how do we solve it? So first of all, let's initially sort all the robots based on their positions. Okay. Now, when will a collision happen? A collision will happen when there are two adjacent robots. By adjacent, I mean that there is no robot between them, and this robot is moving to the right, and this robot is moving to the left. Only then the collisions will happen, otherwise they will not happen. For example, if both of them are moving to the left, then these two will not collide with each other. And similarly, if this is moving to the left and this is moving to the right, then they are moving away from each other, so they will definitely not collide. So we are only concerned with occurrences of some index I and I plus 1 such that the direction of I is right and the direction of I plus 1 is left. Okay. Also, in such a situation, no matter what other robots are present, and doesn't really matter what the direction of the other robots is. This robot might be moving to the right direction. This might be moving to the right. This might be moving to the left. If this robot is moving to the right and this is moving to the left, then first of all, these two will collide. And these before it might be possible that after collision, one of them will die and the other one will, suppose this one remains. So it may, if there is a robot moving to the left here, it may collide with this robot later on. But at this time instance, first these two robots will collide. Then whatever is remaining, after that we will, you know, assess the situation and then we will decide what the further collisions will look like. So at the current instance, we are only concerned with the pairs of adjacent robots which are in R, L direction. Okay. So the brute force method to actually solve this problem would be you could create a sorted vector of positions. Okay. And you could iterate, you could do around n iterations, I think. And in each iteration, you just need to identify any two adjacent robots having which will collide. So if you find these two I and I plus 1 robots, you have a health array, right? You know the health of each robot. So based on the health, you can take a decision. Suppose if this health is 5, this health is 10, then you can remove this element. You can, in the uh, array of health, you can update the health of this element from 10 to 9, and then you can create a new vector containing the elements except this element. Okay, this element will not be present. And then you can keep on, then this element has a health 9, this is position R, uh, because after collision it becomes 9. Suppose then this element here was moving to the left with health 20. So then this and this will collide because there is nothing in between them, and it will move to the left. It's moving with the health 20. So then this one will die. The health of this will be updated from, so the health of this will become I will become 0, and this element's health will reduce from 20 to 19. And then you will remove this element. You will create a new vector of robots based on the same ordering, but just you will remove this element. And this procedure can go at most n times, because every iteration you will try to find one collision. If you cannot find any collision, then you will stop at that point. So the complexity of this brute force solution will be order of n square, because for each iteration you are traversing the whole array to find these R comma L pairs. Okay, so we will do this only, but like we will do n iterations, but we will try to smartly find these R comma L pairs without having to traverse the array. Okay, so what we will do is, suppose let me take this example and let me go down. Let me paste it here. 1 second. Okay. So what we will do is, we want to um, have a data structure which will store all the L comma R pairs. Okay. Basically, it will store all the pair of elements which are adjacent to each other. That is, they do not have any element between them, any robot between them. Okay. And when collision happens, so suppose, sorry, this will be L R comma L pair. I've written it. I hope, yeah, R comma L. So suppose, for example, initially, let me let's maybe maintain a set. Okay. So what we will do is, we will initially do an iteration and we will maintain all the R comma L pairs. So this is an R comma L pair. So we will just store, like we don't need to store everything. We can just maybe store this 11 position, right? And the next index will be the, like we will first uh, store all these elements in a set. Okay, so that set would basically be a pair of uh, position comma index. Okay, so since it's stored in a set, it's only necessary to store the uh, index of the element. So this is the position actually, but the index is 0, 1, 2, 3, 4, and 5 and 6. Okay, if you want, we can let's store the complete pair only. Okay, so let's store 11 comma 13. Sorry, not 3 comma 4 indexes we will store. So this is the R comma L pair. Another R comma L pair would be, in this case there is only one R comma L pair. Okay, Now what we will do is, in each iteration, we will pick any pair from the set, from this data structure or set, that whatever we have made. So from this set, uh, and basically this is a pair that will collide, and we will collide them. So in the first iteration, we will pick this 3, 4 pair from the set. All right. And now we are saying, okay, these elements will collide with each other. So if you look at these two elements, um, you already know the indexes, so you know their healths, correct? Suppose the health of this element is 10 and the health of this element is 2. So after collision, what will happen is, you will first determine which uh, which element or which robot will be. So after collision, one robot or both the robots might get deleted. So you will basically check which element or which robot will get deleted. So in this case, since the health of the fourth index is less, so the fourth index element will get deleted, right? And then you will find the new R comma L pairs. So basically, if you look at this, when these two are colliding, you know the indexes, you know the health. You know, okay, this person is going to die, and this person's health will become 9. Okay. Now, when this person dies, how will the R comma L pair change? So basically, this element to its left, nothing is changing, right? But since this is getting deleted, now previously these two elements were adjacent, but now these two elements will become adjacent. Okay. So you just have to check this new pair. So in the set only, first of all, in this, since you have stored the positions and everything, what you can do is you know this pair, right? So in the set, you can uh, try to find the upper bound of 4, which is basically the next element after 4. If this element is dying, then there will be a new pair which is formed between the element before it and the element after it. All the other pairs, like no other new pair will be added. Okay. So you will just check if these two are R comma L pairs. If they are, then you will add them to the set and you will continue the procedure. Okay. Suppose that the reverse thing was happening in this case, that here we assume the right element was getting deleted. Now let's assume uh, the left element was getting deleted. So uh, this was, let's say this is 2 and this is 10. This is an R comma L pair which will collide. So we will look at so now what will happen is this element will die, correct? So what will happen is there will be a new pair between fourth index and second index, because now there is nothing between them if this dies. So we will basically check if they form an R comma L pair. If they do, then we will add that to the set. So that's the second case. And the third possibility is that you have an R here, you have some index I, you have some index J, which is L, and before this there is an element, after this there is an element, and suppose these are the two elements, and their health are equal. Okay. So in that case, what will happen? Both of these will die, And now what will be the, like, how will the set of r comma l pair change? So basically these two elements will now be adjacent to each other. The rest of the array will not change. So to your sorted set of, you just want to maintain the set of r comma l pairs. So you will check if this is r and this is l. If it is, then yes, you will add it to the set, because then they will collide next time. Okay. Now some implementation details and implementation tricks that you can apply. First of all, um, in the set, suppose in the, so you're maintaining two set. The first set is for the all the set of robots. So you have robot at position p1, p2, p3, p4, p5, and so on. You will also store the indexes of these robots because they are not in sorted order. So, and you need to store their index so that you can find their health and their direction and all that. So you will maintain a sorted set like this. Then what you will do is, you will do one iteration on this entire array. So what you can do is you can have one iterator at the beginning of the set and another iterator just ahead of it. Okay. You will compare, you will basically check itr1 dot direction and itr2 dot direction. And if they form an r comma l pair, then in the set which contains the colliding pairs, you will just add this pair. So if suppose these two, this is R, this is L, so in the set you can add I1 and I2. Okay. And then you will increment this and you will increment this so that now you will compare these two. So that's how you will populate this. Now, how do you handle the collisions and adding the um, new pairs in the set? So suppose you're looking at some pair index I comma j. Okay. So in the sorted set of robots that you had some robot um, having index I, and just next to it there was a robot. There is nothing between them because they are colliding, and you have an index j. So you also need to. So now, like I said, there are three possibilities. If this robot dies, then you will check a pair of this with the next robot, the robot just ahead of it is. Otherwise, if this pair dies, you will check just before this one. Otherwise, if both dies, then you will check these two. So what you can do is you can, since you know the index, you know the position array also. So position of I comma I will correspond to this pair. You can search this pair in the set and this will give you the location of this. This will give you an iterator. This will be iterator 1, let's call it. You can just increment the iterator and you will get the next index, like the jth element. You can increment the iterator again. You will get this value, and then you can uh, decrement the iterator again. So you will get this value. So this is how you can get like the just before and the just after um, robots as well. Care must be taken that if suppose this is the last element of the set, that if there is no uh, robot after this position, then this will point to the end of the set. So in that case, you cannot have a pair like this because there is like nothing here. And similar in this case, if this is the beginning, if this is equal to set dot begin, then this position will also not exist. So in that case, this pair will not exist. So you need to take special care of that. And then based on the health, you can determine which one will get deleted and how the pairs will get added. Okay. Also, a few things which might come to your mind is If there's an R comma L pair and suppose we are deleting this element, is it not possible that this was also forming with a pair with the element next to it, and that should be deleted from the this collision set as well? The answer to that is no, because uh, this is L, right? So next element, even if it's R, then L comma R will never collide. So it will not form a pair with the next element. And similar for this, right? No matter what this is R or L, these two will like never collide. So you will simply delete this pair, and you will either add this pair to the set if this is suppose L, or you might add this pair to the set if this is R and this is dying, or you might add um, this sorry um, you might add this pair to the set. So if this is the ith and the jth index, if both of their health are equal, then they will both die, and then these two will be adjacent to each other. The rest of the array will not change. Okay, so now I will show you my implementation. All right, so in the code, what I have done is I have suppose my R comma L pair is some index idx1 and some index idx2. Okay, so that means in the um, like between those two indexes, whatever their positions are, there is nothing in between. Suppose this is in the set of robots which are still alive. This is that idx1, this is idx2. There is nothing in between. So I can easily find an iterator to this using set.find, because I know the index, I know the position which I can query from the array only that I have. This I will call this ITR1. I can increment this to find the next ITR. I can increment it again to find the ITR next. So this I've called next and this I've called previous. I can decrement it to find ITR, the iterator to the previous index. And then I simply compare them. So if so obviously this has to be R and this has to be L because they are in this collision set. Now all that is left to do is uh, check their healths. If suppose this guy is dying, then you will delete that, and you will check whether this person is of left direction or not. If it is of left direction, then you will add this pair idx1 and idx next to the set, or otherwise you will not add it. And similarly, if uh, this was suppose this was dying, then you would check these two pairs, because there is no point in checking these two pairs because this is L, right? The left one has to be R. So only this, if this is R, then you will add that. And then the last case is if both are dying, then you will check these two. Okay, and special case you have to handle when ITR is the first element in the set, so that in that case this will not exist, or uh, this is equal to, like, this is the last element in the set, so this will also not exist. So in that case you cannot like compare. Okay, so I will show you my code. It's more of an implementation task. Um, so what I've done is I've initially um, made a set, and the set stores for each robot the position and the index it is present at. This stores the collision pairs. Then I have to find the collision pair, so I initialize my iterator to the first two elements of the set, like at the first two positions, and I can the set contains the index as well. So I just use the index. Based on that, I find the directions. If the direction is of R comma L type, then I will insert that. This is a collision which is happening between these two indexes, and then I will increment my iterators. Um, at the end, at the end, whatever robots are alive, I will iterate over them, and I will add their health. And since we have to return the answer in the same order in which it was given, so I will have to sort the answer based on the indexes. So node.ss basically is the index of the robot. So I will sort it based on index, and I will just then return the health. So this is since this is we only need to return the health, so I will just add the health to another returning array, and then I will do this. Now on to the collision handling part. I pick any pair in the collision. find the indexes of the pairs that are colliding. Then I find the next iterator, I find the previous iterator, which I've already shown, and then I compare the healths. So if the first element has lesser health, so that means this element will die. So I will check between this and this. So I will check between previous, which is this, and IDX2. So basically the direction of the that previous robot should be R, and I will update the health. And similarly for the other case around, and in case the healths are equal, then I will uh, erase both of the robots from the set. In these cases, I was only removing uh, the smaller robot, but here I will remove both, and then I will check that compare these two, because now these two elements will be adjacent. So this has to be R, this has to be L. So if this one is R, this is L, then I will insert that to the collision set. So that's how you solve it. So the main crux is you need to maintain the pair of uh, uh, elements which will collide, and you will handle the collisions. When an element dies, the set of collisions, like one of the element might collide with some other new element to its right or to its left. So you have to add that to the set. That's all you have to do. Thank you for watching. Bye bye.